We're now moving into a little bit of a different dynamic, and we're looking into space exploration and what does the future of space hold. I take great pleasure in welcoming Her Excellency Sara Al-Amiri, Minister of State for Advanced Technology of the United Arab Emirates and Chairwoman of the UAE Space Agency, with current Ayozio, to speak on the monumental achievements that have occurred in the space sector over the past few months, and what does the future look like for space research and its governance.
Hello, and thank you again to the World Government Summit for that introduction and for hosting us. I'm so excited to talk to Sarah about all of the excitement around the HOPE mission that is currently orbiting Mars. Sarah, thank you so much for joining us.
It's a pleasure. Thank you, Corinne.
I want to start by setting some context. Because over the last half century, and even more so perhaps over the last decade, space has gotten very crowded. There are a lot of nations launching probes and various missions, most recently 3 missions to Mars alone. Why is it important for the UAE to become among these spacefaring nations?
So exploration was important for us, and it was the next step for the Emirates to go into, and when advancing our overall space sector, and more importantly, advancing our capabilities in both science and technology, and that's both engineers' capability, researchers, and scientists. And this mission was a means towards developing capabilities, and more importantly, it was an entry point for the UAE into space exploration and creating opportunities for engineers to design and develop complex robotics. The HOPE probe is exactly that. And also adventing and including our scientists and researchers and up-and-coming scientists and researchers in the development and the design of such a spacecraft and such a complex system. And today we now have an orbiter around Mars collecting valuable scientific data for the very first time about the Martian atmosphere. And this data is available not only to scientists today, it's going to be available for at least the next 4 years.
And can you tell us a little bit more about the specifics of HOPE's mission? What data is the probe collecting, and what is the goal of that particular data set?
So the mission is observing first the weather system of Mars throughout an entire year, and it's providing us that picture and filling in a gap of knowledge on what happens from hour to hour throughout an entire day, throughout an entire Martian season, throughout an entire Martian year. And that will provide us the very first comprehensive picture of the lower atmosphere and the weather system there. So we saw from the very first image of that the HOPE probe captured cloud features we saw through the atmosphere. It is these features that we've seen in that first visible image that we're going to map and study throughout an entire year. And then we look at how that weather system, so dust, clouds, water vapor circulation, how does that impact loss of hydrogen and oxygen from the upper atmosphere? And we start bridging the gap in knowledge on what role does Mars's weather system play in atmospheric loss. And that helps us understand climate change, and hopefully in the larger context of things, what happens to planets' atmospheres over time. And we use 3 instruments to do that, and our 3 instruments have been successfully checked with the data validated, verified, and ensuring that our data pipeline works properly and our systems are working properly to start off our science mission.
So how would you respond to, obviously we have so many challenges here on Earth. The climate is a big challenge. Over the last year, the pandemic has become such a large scientific focus. What is the value of exploring other planets when we have so much to deal with here at home?
So space exploration and exploring other planets falls under fundamental or basic research. And that area of research needs to remain undirected because the outcomes from it are unknown. And more importantly, the impact and implications are unknown today. And that's an area should remain completely within exploration phase, should remain to expand our human knowledge of what is out there in terms of the planet. And more importantly, why do we study systems around us? It's like studying your neighborhood and understanding where you fit in within your neighborhood. It's the exact same thing when it comes to planetary systems and our solar system. It's understanding what goes on around us. It's understanding how our planet formed. It's understanding how it will transform and evolve by looking around us. And it gives us a lens both in history, and that's what we can find in space, and also in the future by looking at planets that have similar features to Earth. And it's through that are we able to expand knowledge forward and advance it forward. And we always find from space implications down the line. It may not be implications today, but you'll see it in 10 years and 15 years and 20 years. And we're living the byproducts of space exploration. We're living the byproducts of the extent of human questions and the plight to find an answer to those questions.
So if I'm following you correctly, does that then mean that in some way by studying Mars, we could potentially be looking into our own future in a way?
Well, in a way, the two planets are similar. It could be a future of Earth. There's nothing detrimental that links it one-to-one correlation between different planets, but it gives you an understanding of what happens to a planetary system that has features similar to your planet, and it's the closest quote unquote neighbor in our solar system that we can go to that has similar features to Earth, and allows us to better understand our planet, better understand that planetary system. The more we advent into space exploration, the more we can go in beyond using telescopes both on Earth and in space around Earth to study other solar systems, to other planets that are around other stars and at distant galaxies.
Right. So we're going to Mars first because it's right next door, but there's so many other potential Goldilocks planets even beyond what we're able to study right now.
Absolutely. And the more we advance our technological capabilities, the more we make it easier to access outer space, the more we make it easier to send spacecrafts to other planets, the more we can gather data and learn.
Yeah. Speaking of things becoming easier, I would imagine that last year, in light of the pandemic, launching Hope didn't get any easier. It got much harder. Did you have to make any changes to your mission plan, to any of the pre-flight in order to just get the launch off the ground?
Yes, we definitely had to react very fast, make changes as things were evolving, and in some cases even build scenarios that we didn't think were plausible so that we can get to that. So we moved around a lot of the tests. We reevaluated which tests we fundamentally required to do and which tests we've done before and we were okay with not conducting. We changed our entire manpower plan with regards to supporting the mission. A lot of people gave up a lot of their time to be away from their families during the height of the pandemic to get the spacecraft ready for launch, and spent months on Tanegashima Island rather than spending the 1 or 2 weeks that they were scheduled to spend there. I'm really grateful for the team that took us through that final few months to get us to our launch site.
Yeah, because the probe itself had quite a journey. It started in Colorado here in the United States, correct?
Yes. So the probe was started in the United States. We utilized specialized facilities there rather than investing in building our own because there's no point in doing that unless you continuously use it. And that actually drove our cost lower than expected. And then we moved the spacecraft once those facilities were not necessary to our facilities and clean room in the Emirates and Dubai. And once the pandemic happened, we had to reshuffle the schedule so that we can then move the spacecraft safely to Tanegashima Island in Japan, ready for launch.
So clearly a very international effort, but also, again, against the backdrop of a lot of international work pointing straight to Mars. The US has landed Perseverance last week. The Chinese mission arrived within the last several weeks also. How, with all these different missions going to the same place, how do you all stay in contact with each other? Is it a coordinated effort? Are you dividing and conquering, each trying to look at different things on Mars?
So yes, from the get-go for us as a mission, we needed to ensure that we were looking at a part of the science that no other mission was being designed for. At least up to at that point, we could look into the launches of 2022. And it's the openness that exists within the planetary exploration space that allows for you to do that. And the second part is the assembly of the scientists. So we had scientific objectives. MEPAC releases scientific objectives about Mars that are important. So you can rely on a base that collects science objectives and science questions that have been unanswered. And then you've got an openness within the community that directly speaks about the missions that are going out there, what questions are addressed. And you're able to then, as a new entrant, design a mission that you're not replicating other missions. And the more you enter into this field, and that's what's happened with us on this mission, the more you better understand what is required from other scientists, and designing a mission towards that then becomes easier.
And so HOPE, as you said, is focused on the weather and getting a full year or orbital view of that. And it's also concerned with the atmosphere. Are there plans for what you will look at after HOPE?
So in terms of the mission itself, there's an extended mission built into it that we will design a year into collecting data, an Earth year into collecting data around Mars. So that's half a Martian year. In terms of other programs, what we're currently looking at is so our first advent into planetary exploration is to transfer and expedite the transfer of know-how and knowledge into the space sector of the UAE. What we're currently designing and developing is how do you transfer that onto creation of a private sector, first for Earth observation, and then hopefully jumping into what the US has done successfully, which is allowed for a private sector to exist, or provided a value proposition for the private sector to exist in exploration and to aid in exploration.
And would those private sector efforts be directed to some degree by your agency? Would you be working similarly to the US, where there are particular objectives and then you're looking for companies to engage with you and work on them?
So it's twofold. It's one, ensuring that the space agency enables an overarching ecosystem, and you need to ensure that that's not directional. And you allow for investors and for innovators to develop whatever area within the space sector exists. So that's one way that we're tackling it. The other way is by ensuring capability and capacity developing according to priority areas, because that's the only way we can function as an organization, is in directing funding towards one particular objective, build up that area of the space sector, and then move on. And those are two aspects by which we are enabling a private sector within the Emirates.
Yeah. Have you set the first set of priorities yet? What are the next things that you hope to be able to look at, if you've decided on them yet?
So first, the entire region is a new entrant, especially when it comes to being a player in the private sector, either in designing systems or in producing data. So the first is to elevate the demand for space products and services, and at the same time to build an understanding of what other sectors could use products and services from space. So we're focusing on team companies, and that is easy to start up, because you don't require a space asset. What you're doing is relying on data that's already being collected with the Earth observation and catering to different sectors. The other aspect is to also capitalize on small satellites. So with the ease of access to space now, and the lower cost of access to space, you're able to develop and streamline the development of small spacecrafts that are utilized for various uses. And that then becomes the second prong by which you are enabling companies in designing of space systems, and then you go into subsystems. So that's sort of an overarching bird's eye view of what we're doing and how we're tackling those developments. And underlying that, like I said, we need to ensure that our legislative process is easy for companies to be established, especially in technology. There are means to provide funding through various aspects. Talent is very important for us, so there are means to be inclusive when it comes to talent. Space is very diverse, and therefore we need to ensure even our ecosystem is very diverse to those that are in the Emirates and those that are interested in coming from outside into the Emirates to join the space ecosystem here.
Right. And part of that does come from, again, the international community, the places where the knowledge has already been built to bring them in and make them part of your ecosystem, your world as it exists within that larger community.
Absolutely.
So the last question I want to ask you is a little bit of the pie in the sky question, right? Because in the near term, obviously, we're looking at probes and orbital observation of Earth, orbital observation of Mars. Is human spaceflight in the roadmap?
A human spaceflight is actually a program that's established for the Emirates, and that's part of the exploration space program that the UAE is looking at. So that's definitely ongoing. Same thing with our science advent, and then we've got the private sector. For me, is a new area to be established. So the ecosystem needs to be comprehensive. It needs to include both scientific endeavors, private sector endeavors, and at the same time, the large, risky projects that governments support.
So it's those large, risky projects that get all the headlines, like when an orbiter makes it to Mars. That must have been a very exciting day for you and your team.
It was, after those long hours and those painstaking times on not knowing what we're going to reach success or not. That day was remarkable for the entire team.
Were you confident, or is it just you never know because it's space, so there's always nerves?
There's always nerves. We were confident that we've done everything in our hands to get to the point that we're at, and that we've tested the system to the exhaustion of the system and understood it very well. But you can never be too confident in space exploration. You can never be confident if you're putting another object in orbit in another planet. So we were not comfortable as a team, even with the knowledge of what we've done to prepare for that day.
Well, congratulations to you and your team. It is quite something. I can't wait until we start seeing data coming back. And with that, I think we will wrap it up. Sarah, thank you so much for your time. It's been a really interesting conversation.
Thank you so much. It's a pleasure, Corinne.
Thank you, Your Excellency and Corinne, for that highlight on the space sector and scientific research.